We're now going to turn our attention to another interesting dimension of structured task scopes. In particular, how can you implement a structured task scope that's been customized? And I'll start, of course, first by motivating why you would want to do that. Why would you want a custom structured task scope? And then we'll take a look at how you could do it if you needed to do it. So keep in mind before we get into this that there's two nested subclass implementations of structured task scope that come out of the box, and that is shutdown on failure and shutdown on success. So you should be familiar with those before we get much further. So we're going to talk about how and why you would want to implement a custom task scope. So first, let's motivate the need for one of these things. So the shutdown on success nested subclass of structured task scope works fine if the first task to complete provides a valid value, a value that you can use. So here's an example. We took a look at this example before where we're going to both quicksort and heap sort a list at the same time. And we don't care which one finishes first. We just want the result. And quicksorting and heap sorting will return the same result. So either result is perfectly OK. So we don't care. Whatever finishes first, that result is successful. We're done. However, if the first task to complete provides an invalid value or a missing value or something else, then shutdown on success isn't going to work the way we want. So let's take a look at a simple example to illustrate this point. So what we're going to see here is that we're going to have an array of random integers, and we're going to try to find the first prime number in that array of random integers. So that's what we want. We want to get the first prime number. That's our requirement. And so what you see here is we're going to have a shutdown on success scope. We're going to want to get an integer back, the first one that's going to be non-prime, sorry, the first one that's prime. And so we have a numbers array. For each number in the numbers array or the numbers list, we fork off a task to check to see if the number's prime. And we do that, of course, because checking the primality of a large prime number could take some time, so it perhaps warrants using multiple threads. Well, isPrime is going to return something. Let's assume it's either going to return a Boolean, or maybe it returns 0 if the number's prime, and otherwise it returns the smallest factor. Well, whatever it returns, if the number is prime, we want to give back the number, because that's what we want, the first prime number. But if the number is not prime, we still have to give something back to fork. Fork has to return a value somehow. And so in this case, what's going to happen is we're going to return null to indicate that it was not a prime number. Well, what's going to happen if we use shutdown on success is that the first result that returns null is also considered a valid result from the point of view of shutdown on success. It's just giving back a null result. It doesn't realize that's not what we want. So what will happen is if we end up getting a null back before we get a number back, then when we join, we're going to get a null back as the result, which is not what we want. We want to get the first non-null result back, if that makes sense, the first prime number we want as the result. And so notice here that this lambda expression that's being passed into fork is going to return a value that fork then uses to make as the result of the concurrent computations. So that's a problem. So to solve this problem, we have some options. And one of the great options is that the designers of the structured task scope, structured concurrency model in Java were clever, and they made it possible to customize structured task scope to take control of how the behaviors work to decide what constitutes a successful result. And so what we're going to do is we're going to come along, we're going to basically inherit from structured task scope, and we're going to override a particular method that is defined there. So let's take a look and see how to do that. So it turns out that structured task scope can be extended, as we do here, and we're going to define our own little class, which I call ShutdownOnNonNullSuccess. So it's still a shutdown on success-like thing, but this time it's going to shut down on the first non-null successful result. And you can see this code here, and we'll look at it in the next lesson. So what this does is it's going to capture the result of the first subtask to complete successfully, in other words, without returning a null, or if there was absolutely nothing that matched what we were trying to do. If we looked in a list of randomly generated integers and none of them were prime, we'll just get back a null. So that means there were no results. It's not an error, it just means that there was no matching results. So let's see how we do this. We're going to define a local field called mResult of type t. T is the parameterized type. And we make it volatile. What volatile means, volatile is a keyword. You can read more about volatile at this link, that essentially tells the Java runtime, make sure that reading and writing to this particular field is atomic. So we want reads and writes of that to be atomic, and you'll see why we need to do that here in a second. And then there's a method defined in StructuredTaskScope called handleComplete. And handleComplete is a hook method that you can override and then write logic to decide when the scope should be shut down on success. And so that's what we're going to do. We're going to override handleComplete. Now, handleComplete is passed a future whenever the task that that future corresponds to has completed, either successfully or on failure. And so we get a future here, and this is our hook to decide whether or not we want to shut down. So I've omitted a little code that we'll take a look at when we walk through the complete implementation in a second. But assuming that everything went well and this thing shut down successfully, we get the result from that future, and we check to see if the result is null. If the result is null, it means we don't want to shut down because we haven't got a successful result. We got a null result. But if the result is non-null, in other words, if the result doesn't equal null, then we store the result that we got here into mResult, which is that field, and then we call the shutdown method. And shutdown basically shuts all the other threads down that we're running and ignores any results that they may have. So that's how we're going to be able to get the final result. So after this happens, after join returns in the scope where this thing is used, we can then call the result method. We'll get the result back, which will either be null if nothing completed successfully or non-null, and otherwise will be the value that was the first successful completion, i.e. non-null completion. So that's the end of the quick overview of implementing how and why, or maybe better, why and how to implement a custom structured task scope.